Good morning, students. Next continuation after those four theorems. One is quotient theorem, product theorem, sum theorem, right? And constant multiplication of derivative. Now, next example is let h of x is equal to x power minus m. For x not equal to 0, we are going to find the derivative of this one. Simply by ordinary differentiation, suppose x to the power of 2. What is the differentiation of this x to the power of 2? Differentiation of x square is 2 into x, right? Similarly, x power minus 3, here power is negative. In this case, how to find a derivative? Same formula, minus 3 into x to the power of minus 3 minus 1. On simplification, minus 3 into x to the power of minus 4, which can be written as minus 3 by x power 4. This is ordinary differentiation. What is the general formula? Suppose x power n, differentiation of x power n is n into x power n minus 1. Similarly, x to the power of minus m differentiation is minus m into x to the power of minus m minus 1. Right? The same thing we are going to here. We are applying the definition of a derivative. Right? Now, see, to solve this problem, let h of x is equal to f of x by g of x. Now, where f of x is equal to 1 and g of x is equal to x power m. That means, suppose if you write 1 by this x power m can be written as x power minus m can be written as 1 by x power m. No, this numerator we are denoting it by f of x, and this denominator we are denoting by g of x. That's it. Right? Now by quotient rule, we know that already quotient h dash of a, the derivative of h at x is equal to a is g of a minus g of a into f dash a minus f of a into g dash a by g of a whole square. Right? Therefore h dash of a is equal to g of a is, we know g of x. What is g of x? X power m. G of a is a power m minus f of x is equal to 1. Differentiation of a constant is 0 minus next f of a. F of a means 1 only, because there is no x means 1 only. Now g dash of a, we know that m into a to the power of m minus 1 by g of a whole square. That means a power m into a power m. A power m into a power m, that means a power 2m you will get, right? Now see, h dash of a is equal to, on simplification, minus m into a power m minus 1 by a power 2m. Again, transport this denominator to numerator, we are getting minus m into a power m minus 1 into a power minus 2m. Right? Therefore h dash of a is equal to minus m into a power m minus m minus 1. This is plus, this is positive, no? Here m minus 1 plus of minus 2m becomes minus m minus 1. Therefore h dash of a is equal to minus m by a to the power of m plus 1. Right? Minus of m plus 1, which can be written as, see here, if you want to take a power minus common m plus 1, this can be written as a by m plus 1. Right? Now, therefore, for a not equal to 0, we write n for m. The derivative of x power n is n into x to the power of n minus 1 for negative integers n as well as for positive integers, whatever it may be. Right? See, application. For negative for positive integers, I am getting 2x to the power of 2 minus 1. Suppose x to the power of minus 3 means same formula we are getting now. See here, x power n derivative is n into x to the power of n minus 1. If it is negative power also, the same formula, the same result you will get. Right? For negatives and positive, that is the general formula. X power n is equal to n into x to the power of n minus 1. Next one, important one is chain rule. Right? Now, if f is a differentiable at a and g is differentiable at f of a, then composite function g circle f, this is called g circle f, is differentiable at a, and g circle of whole dash of a is equal to g dash of f of a into f dash of a. Right? Now, see, this theorem statement is very lengthy one. Now, before going to prove this theorem, now see here, discussion. G circle f of x can be written as minus g circle f of a. This can be written as, see, this function, g circle f of Now g of f of x minus g of f of a by, now here f of x minus f of a. Here I am multiplying and dividing by f of x minus f of a. Now these two gets cancelled. No, see, this one and this one gets cancelled. Again you are getting x minus a. Here what we are doing, multiplying and dividing by f of x minus f of a. If you want you can write like this. Wait, here multiplying and dividing by f of x minus f of a. F of x minus f of a. See, here rearranging terms, we are applying the limit on both sides. Limit f of x as x tends to a is f of a, that we know, that means f is continuous at x is equal to a. Limit x tends to a, g of f of x minus g of f of a by f of x minus f of a. Now here I am assuming f of x is y. Limit y tends to f of a, right? G of y minus g of f of a by y minus f of a can be written as g dash of f of a, or you can write g dash of y, where y is equal to f of a. Now limit x tends to a, f of x minus f of a by x minus a can be written as f dash of a. This is the definition of differentiation of f at x is equal to a. So from 1 and 2 combining, g circle f whole dash of at a is equal to g dash of f of a into f dash of a. This statement is కొంచెం కష్టం అనిపిస్తుంది, బట్ ద థింగ్ ఈజ్, సపోజ్ వన్ ఫంక్షన్ ఈజ్ గివెన్ టు యూ, sin e power x, find the differentiation of sin e power x. Here what you will do, differentiation of sin is cos e power x into inner function we have to differentiate, e power x differentiation d by dx of e power x, which is nothing but e power x only, right? Now you will get answer e power x into cos e power x. The differentiation of sin e power x is like this. So another example, sin of log x. Sin of log x. Here this is a composite function. Here see, if you want to find the differentiation of this one, differentiation of sin is cos, differentiation of sin x is cos x, differentiation of sin something is cos something. Now differentiation of this one is cos of log x into inner function d by dx of log x we have to write. Now cos of log x into differentiation of log cos x, log x is 1 by x. Therefore answer is cos log of x by x is the differentiation of sin of log x. Here this is a composite function. This is nothing but g circle f dash of a is nothing but g dash of f of a into f dash of a, like this, right? Now see, this entire thing is statement. This is about this is an explanation of g circle f and the derivative of g circle f and the derivative of f dash of a at x is equal to a, right? Now the proof, where f is, what is f? F is a continuous and differentiable function at x is equal to a. G is a function differentiable at f of a, right? Already it is given in the statement only. Now g circle of f of x is also a composite function which is continuous. G circle of f is defined on some open interval containing a. Now here let we are denoting h of y by g of y minus g into f of a by y minus f of a for some y belongs to domain of f where y is not equal to f of a, right? If y is equal to f of a, it becomes a 0 by 0 infinity form, no, right? Now see here, now let h into f of a is equal to g dash of f of a. If you apply the limit, where y is equal to, assume that here y is equal to f of x, right? Then if you apply the limit as y tends to a, this means limit y tends to a, g of y minus g of f of a by y minus f of a can be written as g dash of f of a, right? Now by the definition of derivative, now see, since limit y tends to f of a, h of y is equal to h into f of a. This is the definition of continuity, right? You know that limit now x tends to a, f of x is equal to f of a means what? F is continuous at x is equal to a. Similarly, limit y tends to f of a, h of y is equal to h into f of a. That means h is continuous at at y is equal to f of a, right? Or now next, the function h is continuous at f of a. Now consider g of y minus g into f of a is equal to h of y into y minus f of a. From where we are getting this one? From the first one concept, right? If you cross multiply this one, g of y minus g into f of a can be written as h of y into y minus f of a. From this point we are getting this result, right? Now see here, g circle of f of x, which can be written as g circle f of x is equal minus g circle f of a is equal to h into f of x into f of x minus f of a for all x belongs to the domain of f, where y is nothing but f of x. Now we know that. Now hence g circle of f of x minus g circle of f of a is equal by x minus a is equal to h into f of x into f of x minus f of a by x minus a. What we are doing? We are both sides we are dividing by x minus a. If you want, you can write both sides dividing by x minus a, right? Now and then we apply the limit x tends to a, f of x is equal to f of a, and the function h is continuous at f of a. Limit h tends to a, h of f of x is equal to h into f of a, which is nothing but g dash of f of a. Now again we know that limit x tends to a, f of x minus f of a by x minus a can be written as f dash of a. This is the derivative of f. Now thus are taking limit in equation number 3. See here, equation number 3 is this one, right? Now we obtain g circle f dash of a is equal to g dash of f of a into f dash of a. This is called chain rule. This is called chain rule. Now and a problem based on the chain rule is a simple one. See, example, let h of x is equal to sine of x cube plus 7x for some x belongs to R. Find h dash of x. Now what you are going to do? Ordinary differentiation. Suppose sine of x cube plus 7x. What is the differentiation of sine? Is nothing but cos x cube plus 7x into d by dx of inner function x cube plus 7x. Cos of x cube plus 7x into differentiation of x cube is 3x square, differentiation of 7x is 7. This is the answer, right? Now here we are applying chain rule. See, by applying chain rule, h is equal to g circle of f, where f of x is equal to x cube plus 7x, g of y is equal to sin y, where this is nothing but y. Now see here, f of x is equal to x cube plus 7x, f dash of x is 3x square plus 7. G of y is equal to sin y, g dash of y is equal to cos y, right? Now by chain rule, h dash of x can be written as g dash of f of x into f dash of x. Now what is this one? G of x is or g of y is sin y, no? Similarly g of x is cos sin x. Similarly g dash, differentiation of this one is g dash of y is cos y, g dash of x is cos x. Similarly cos of f of x into f dash x, cos what is f of x? X cube 7x into f dash x is 3x square plus 7. Therefore h dash of x is equal to 3x square plus 7 into cos x cube plus 7x. By chain rule we are finding the differentiation of composite function. The next chapter we are going to discuss about the mean value theorems. These are very important theorems, mean value theorems, right?